Firstly, welcome. And this morning we're going to have a conversation with a couple of subject matter experts and our Intel VIP Bob around the three key tenets that we've heard about this morning. In particular, the use of analytics to gain a competitive advantage, learning from the early adopters and their successes and where they've gained some wins, and also what's not working. In other words, learning from our mistakes. What can we avoid? How do we avoid the pitfalls that others have had? So in keeping with the theme of real-time and predictive analytics, we're going to do this in a slightly different format. We're going to do this in a speed dating format, rapid fire as it were. So think of me as your chaperone today, and my role is essentially to help you fall in love with our panel and their insights. Although I think my job is essentially already done anyway, but don't tell anyone that. So let me introduce our panel first. I have the pleasure of introducing Bob Rogers. So Bob is you're the chief data scientist at Intel. I understand your career started, you were an astrophysicist originally, building models, computer models for supermassive black holes. And then in 2006, you transitioned into healthcare with Carl Zeiss Meditech, and then went on to found your own company in health in particular. And with Intel's recent announcement of their new chip, I think you'll have to pardon my pun that your life is quite literally nirvana in that in many ways you now have Intel's neural network processor at your fingertips. Dr. Michelle Gong from Montefiore, welcome. Oh. Thanks for joining us today. So Michelle, you're the Director of Research and Academic Affairs at Montefiore Medical Center in the Division of Clinical Care and Medicine at Montefiore Medical Center and at Albert Einstein College of Medicine as well. And Jonathan Donaldson from Google. Welcome, Jonathan. Thanks for joining us today. You're the Technical Director for the Office of CTO inside Google's Cloud Division. And I understand your challenge day to day is to help enterprise clients through the transition to a cloud-first approach. That's right. So welcome. Thank you very much for joining on stage today.
Thank you for the invitation.
So let me just set the scene for our speed dating conversation today. Essentially, we want to take you on a bit of a journey, a bit of a storyline. And as we take you on this journey, we want you to picture this whole transition we've been through from mainframe to then cloud, and then big data and analytics on top of all of that. When you think about the journey we've been through with the transition from traditional data processing to then adopting business intelligence to gain insights from the data we have, to then big data and analytics. Today we're going to hear from two subject matter experts and their story about how they've applied Intel's technology to the challenges they faced in the case of Michelle with medicine and with Jonathan with some of their clients, and how they've navigated that challenge and the journey of adopting and leveraging analytics in their day-to-day life. But first, let me just set the scene with a couple of key points for yourself, Bob. Let's talk about some of the key value propositions. So we know that Intel does a lot more than just the Intel Inside story that we've heard so often. I don't think it's any secret that Intel's a leader in storage and networking and security and data centers, for example, and much, much more. But Bob, if you're at a dinner party and somebody asks you to describe in layman's terms how Intel's technology supports partners and customers to do great things in cloud and big data analytics, how do you describe that?
Well, first let me say it's much easier to do that now than when I was an astrophysicist. But so the first question people ask me is, Chief Data Scientist, isn't Intel a hardware company? Why do you need a Chief Data Scientist? And so the answer is that if our customers, that is the end users of our technology, can succeed with analytics and really achieve what they need to achieve in terms of competitiveness and answering questions that they need to answer, then they're going to invest more in their infrastructure, and that benefits Intel and creates a virtuous cycle. So the whole idea is for us to work with end users and partners to create a vibrant ecosystem for analytics and AI. So how do we do that? Well, first of all, we make huge investments in developing and contributing to open source technology so that all of the different key components of analytics infrastructure are out there and available for people to use easily, and of course optimized to work really well on Intel hardware. Furthermore, with our software vendor partners, we do the same thing. We're one of the largest software companies in the world, even though we don't sell any software. And the entire reason for that army of software developers to be in existence is to work with our partners to make sure that their software runs as well as it possibly can on Intel hardware, and to feed back where we can make improvements in our roadmap to really keep serving their needs. So that's the first part. Then the second part is literally working with end users to help them understand how to move on that journey that Lisa so beautifully described. There are a lot of opportunities with data, but also a lot of challenges. So we take our experience, work with our end users, and help them get down to asking the questions that they need to answer. Because at the end of the day, analytics is about answering questions. So if you can ask the right question, you get value from your analytics.
Perfect. So let's now take you on this journey that I promised. And in particular, some things that I'd like you to take home that you can actually apply in your own organizations, whether you're a small, medium, or large enterprise, around the common challenges that you're going to face as an organization in adopting analytics, in particular, why we do it, and what benefits analytics and big data can offer. So with that in mind, let me throw to Jonathan. Let's hear about some of the things that both of our guests have seen in, I guess, their start of their journey. Jonathan, with yourself, I don't think it's any secret that Google, more than any organization on the planet, I might say, and correct me if you think I'm wrong, have been on this lifetime journey in big data and analytics, and particularly the transition from historical analytics and indexing things and searching and collating data on the internet as the largest search engine, through to near real-time and then predictive analytics. Could you share some insight into kind of what that's been like, not just for Intel, but where you've been able to take those learnings and actually apply them to a customer project?
Sure. So I would say, probably one of the biggest things to think about is, Google has been doing analytics for a long time. And a long time is 14, 15 years now at least, right? So about 2003, 2004, we released the papers on GFS and MapReduce, right, which became kind of the seed for what later became Hadoop and other things like that, because that was what we were using internally, those types of concepts to get better customer experiences, right, for those people that used search and Gmail and all the different things that people come to Google for. It was for a customer intimacy perspective, for understanding what the customers want. It was not just quite good enough for be able to, people type in on the search bar, recipe for, something, right? And then just be able to hit enter and then have to go through and search things. One of the things we found is that if you can start to, historically look back, almost in real time, but not quite real time. So again, still kind of the data analytics from the things that you've seen before, go back through that and look at what you can then provide customers. That's when you start to see the things pop up, like as you're typing, recipe for, and then you start to, like around Thanksgiving, you start to see, recipe for turkey or, gravy or turkey gravy or those types of things. And so that really drove people to use the search engines more and more because it felt more intimate to them.
It's like it's reading your mind.
Yeah. And then we've transitioned from that on through, and again, so we were doing we were doing data analytics back, 14, 15 years ago, and then we've transitioned from there, right? So we still do a tremendous amount of kind of historical data analytics, but what we've now transitioned to is now we kind of understand the data and how it's formulated and how it's consumed and how we can actually derive insights from that. We've actually started to transition from that into the machine learning side of things and predictive models. So basically being able to use all that information now we've pretty much labeled, run it through the machine learning algorithms, basically then create the models where now we can, instead of having to look through predictive or look through historical data to get those analyses out, we can give those kind of in real time for not only for that search, but Gmail introduced this recently where it'll automatically look at your an email to come in, and when you go to reply, it'll offer you kind of the three boxes at the bottom that says, here's kind of 3 canned replies that you can click the button on and be able to, get your time back, get that email off even quicker.
And I don't think it's any secret that they're the kinds of things that we're trying to achieve now at the enterprise level. I mean, we're not all Google, but we're trying to get to the point where we take data and we put it into, let's say, a small data lake and then gain those insights. But we want to do that in near real time or in a predictive form, because I think we've seen all too often people come to a meeting in a boardroom and they've got printouts on paper with graphs, but that's yesterday's news or last month's figures, as opposed to now what we want to do is walk in with a tablet computer and actually get real-time dashboard and data around that. So let's now look at a couple of other examples here. So I'd like to talk about the topic of competitive advantage. So why are we even doing analytics in the first place? Why would any of you go home and try and bother driving some kind of business initiative to adopt big data and apply analytics to it in data science? Michelle, could you perhaps give us an outline of the Montefiore success story you have? I mean, it's an amazing story to share. In particular, your clinical risk scorecard and the competitive advantage that it gave you and Montefiore and your team around you in your war against critical organ failure and saving lives.
Thank you. So, as you might guess, I'm the odd duck in this panel. But in many ways, actually, I'm perfect because actually I want to be able to describe how predictive analytics can actually even benefit odd ducks like Montefiore and myself. So I'm a critical care physician at Montefiore Medical Center, which is a typical academic medical center with 620 beds or so. And most of the patients in those beds are actually getting the treatment and responding to treatment on their road to recovery. But for whatever reason, about 1 or 2% of those patients, in spite of getting the appropriate treatment, starts to not respond and then to deteriorate. And in some ways, they represent a needle in the haystack. And as a critical care physician, my job is to take care of the sickest patients in the hospital. But there's no way that my colleagues and I can cover 620 beds plus the entire emergency room at the hospital. So you may ask, well, what about the other doctors and nurses, and couldn't they actually detect? And they do, and that's how we find out about them. They call us, and we go and we help out. However, my research has shown that in spite of actually the vigilance of the clinicians, we see subtle signs of changes in the patient's conditions hours to even days before they call us. And now, why is that? The typical patient in a hospital of the modern medical system generates about 300 to 1,000 data points a day.
Wow.
What that represents is a big data problem and information overload for our clinicians. It's just not humanly possible to process that much data into a coherent pattern and to do it consistently. What we needed was something that would develop a 24-hour, 7 days a week surveillance that is never tired, that is never sleep deprived, and is always consistent. And as a researcher for the last 2 decades, I've come to realize that this is where all of the sophisticated statistical tools that we have that grounds our medical research was not necessarily enough in this situation. There's just too much data in the modern healthcare, and the events that I'm looking for is just not that common.
Right.
So this is when we actually turned to machine learning algorithm, predictive analytics, and my colleague and I, Dr. Parsa Mehaji, who's an informaticist and data scientist at Albert Einstein in Montefiore, powered by actually the infrastructure provided by Intel, was able to actually harness the data in our electronic medical records to look for patterns that are consistent with patients who may be deteriorating in the hospital. And we have geared that to alert the physicians to the fact that their patient may be at a high risk. And our goal here is not to replace the doctor. Okay? I still think actually the clinician is absolutely vital. The goal here is to help with their work, help with their effort. Is to alert them, to get them, to bring them to the bedside, to reevaluate their patient and see if things have changed, and maybe there needs to be another assessment of their plan. And actually, as a result of this work, we were actually one of the few sites across the country to be awarded a 5-year NIH grant to precisely look at whether or not an earlier detection of patients who are clinically deteriorating might actually improve their outcomes, and they're a function of life afterwards.
That's amazing. I was going to say one thing that strikes me in hearing your story, Michelle, is that there's a great comparison with what Jonathan talked about, a pattern that I see everywhere, that machine learning and AI have great power to augment people in what they do by creating scale. You know, it's too much data. The data is too fast. It's too much to review, and so it's actually a really interesting point there.
And I think you probably already confirmed this, but I think in many ways when we look at the whole big data analytics and data science practice, we're learning that we can only get so far with machine learning, deep learning. There is still human curation, and as you're saying with your specialists in various areas of practice of medicine, they're effectively curating the last mile, if you like. Could you maybe just recap? We had a great conversation the other day about the moment at which you realized you had too much data and you needed some help to deal with that. Could you just give us a quick summary of kind of how you went from the realization you needed some help to then essentially reaching out to the team at Intel and the key things they went through with setting up your proof of concept and some trial gear and just that basic journey of getting started? Because I think everyone here could take a lot away from it, because we all reached this point where we know we've got a problem, we've actually figured out a business issue we're trying to solve, we've got the question, we just don't have the answer yet. And the likes of Intel's team came to help you through that process of getting started and up and running through to deploying it in production.
Yeah, so that came about a realization that actually we were dealing with real healthcare and real patients.
Right.
So in a lot of clinical studies that we do, we look at actually a subset of data that we need for a particular clinical trial or a particular type of research. But actually, when you're working in the real world, the reality is there's a ton more data. So I just told you how much data patients are being generated, and we realize actually our current healthcare system with all of our servers to power our very comprehensive electronic medical records is not necessarily enough. We need actually higher computing power and the servers to be able to do that. And that's actually where Intel actually stepped in.
Right.
And provided above and beyond our grants some of the infrastructure to allow us to be able to take this, and this is hundreds of thousands of data points through every patient in the hospital from the time that they show up in the emergency room to the time that they leave, and funnel it into a system where we can systematically calculate these scores to indicate the high risk, and then to integrate that within our electronic health records so that from the clinician point of view, it's seamless. You don't have this system telling me one thing and then this system telling me another, and then I need a third system to look for the data. It is now seamlessly incorporated so that within the same system, they are alerted when something is happening.
And I think we're all going to be aware of this. I mean, for most organizations, we don't have a dedicated practice in place just by default for any of these key challenges around establishing the capability for a compute platform, a big data practice per se, unless we've got a team of actuaries lying around. And so there is a point in time in almost every project I've seen where we call to somebody like the Googles and the Intels of the world to come and help us. Jonathan, I'd like to bring you back in here. We were talking earlier, and you gave me a great anecdote about a project that you work with clients. I would love for you to share some of that story, particularly around how you helped them avoid some of the common pitfalls associated with I guess what Google's now famous for in this fail and fail fast approach. Tell us about that story and how Google brought some of your insights and learnings to that huge big data problem you were sharing before.
Yeah, so obviously a couple flavors on this, right? So the fail fast, right? It's kind of the mantra out there, and we like the fast part rather than the fail part. But if you, so how many people here use Gmail?
Yeah.
Exactly. Thank you, by the way. One of the things you may not be well known is that Gmail was actually what we call a 20% project, and a lot's been written about how Google does these 20% projects, where if an engineer has a good idea, right, he or she can go facilitate that idea on the infrastructure and see if it actually plays out. And the way that we kind of got through the common pitfalls is traditionally setting up that kind of an infrastructure, whether you're doing things like mail, but then adding analytics or just big data type of things or machine learning, right? That's very, very complicated. It takes a long time to set up, so it doesn't really jive with the fast part. And so one of the ways that we got around that was we actually provide the same types of services that people would use in Google Cloud internally and have been doing that for many, 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 many years. In fact, most of the external services that we offer from a Google Cloud perspective are derivatives of the ones that we've been running internally for half a decade or longer.
Right.
And so that's one of the ways that we get around kind of the fail, fail, fast thing is we want them to actually work on their time actually doing something that's important to actually get to whatever that goal is that they're trying to do, rather than having to spend all the time spinning up the infrastructure internally. And then if it actually does take off, it's very easy to platform into production since it's already on our systems in a very standardized way. One of the ways that we've kind of worked with external customers is Global Fishing Watch is one of those that they're a nonprofit that looks for illegal fishing that happens in areas where maybe the native population of fish have declined below certain levels. And so one of the ways that they've done is they take in from about 200,000 ships per day, about 22 million GPS coordinates every single day, run that through the Google compute engine for normalization and for tagging of what's maybe a cruise ship versus a shipping vessel versus an actual fishing vessel. And then they run that into BigQuery where they're able to actually run reports against, because they can also then sense, right, through some of the machine learning activities on there in that initial ingest of information,
Right.
they can determine if something is actually fishing or not fishing. And then is it just passing through an area that might be protected? And so then once they actually have all that normalization, the tagging of where it was, when it was, and what it was doing into BigQuery, then Global Fishing can then actually run reports and then give that to the local governments to say, this vessel was actually fishing in an area it shouldn't have been fishing, right? Reducing the native population even further, that's a problem. And I think to date they've been able to find about $2 million through the local governments on those vessels to kind of make sure that
Wow.
the oceans are safe. Yeah.
I remember reading a report a couple of years ago where a particular part of Europe's oceans were overfished, and they were estimating a 10,000-year recovery time for that particular space to recover from it. So it's a very real problem we've got. Bob, I'd like to bring you back in if I could now. When you walk into a boardroom with some of the amazing people in this room, you often kind of end up in that speed dating experience yet again. Picture that I'm a CEO, you've walked in the room. How do you, in 60 seconds or less, convince me that some of the standout learning around big data and analytics and machine learning that you've had at Intel is going to get me across the line from I think I have a need versus I do absolutely have a need?
Thanks, Des. So you set the scene nicely. So the first thing I ask is, and I'm going to ask all of you, raise your hand if you've heard that data is the new oil. Okay, now if any of you didn't raise your hand, you weren't listening to Lisa, because I know she said it. Anyway, so data is the new oil. Yet, and you're inundated with data, there's no doubt, but is data itself the value? I ask, do you put oil directly into your gas tank? No. So there's a process that you need to get to value from data. By the same token, your competitors are mining that data and getting value from it. Why is that? Why is that happening right now? Why is this the topic of the day? Well, first of all, we've got unprecedented access to data through things like Google, through all our different channels that we're generating data. So access to data. We've got unprecedented computing capability thanks to, for example, Intel and the Xeon Scalable processor, et cetera. So you've got that. And then finally, we've got a lot of new techniques for getting value from data in machine learning, analytics, and especially recently in artificial intelligence that are really upping the ante on that. So to you, the board, what I say is, let me take you on a journey to figure out how to ask the right questions of your data so that you can get to the value and the outcomes that you're looking for.
And I really do like that data is the new oil analogy, but I think when we were talking earlier, we qualified this with the view that oil in its original form is crude, and it needs to have some form of refinement to become a petroleum fuel,
Absolutely.
or diesel or petrol or kerosene and so forth. And I think it's fair to say that data is the same. And Michelle, I'm going to come back to you in a second to qualify this, because too often we look at this data is new oil, but we forget that there's the refinement and the classification and the validation and the proof on the data before we can actually get some insight, in the same way that oil's got to be converted from crude to petroleum. Michelle, if I can come back to you, are there some examples of unique challenges, and I'm sure you have a lifetime of them given the space that you're in, some of the challenges you faced establishing the actual analytics capability itself? So you realized you had too much data, you needed to get some help from the likes of your friends at Intel to do that. But were there particularly unique challenges that you faced in health that maybe folk in the audience today could take home and learn from and hopefully adopt as well?
Yeah, the challenges are many, but that is true of any kind of technology that we adopt. So, one of our challenges is we want to be as sensitive as possible in picking out those patients who are clinically deteriorating. But there's a cost. The greater the sensitivity sometimes come with a greater false positive rate, which leads to actually potential for alert fatigue among our clinicians. So we have to find that right balance. In addition, clinicians, and I don't know that they're any different than, say, any one of us out there, but they're a little bit more skeptical about predictions that come out of what they consider a black box. And what may happen is that you get one false alert from the black box, and they say, proof that doesn't work, right? It's proof. Meanwhile, they may make problems in terms of their own predictions or their own judgment, but there's a million reasons why that was an exception to the rule.
Right.
Right? So there is a certain amount of human skepticism that we had to overcome, and this is partly human factor engineering. It's like anything else with any kind of tool or anything new that you implement. It's only useful, actually, if I implement it in the right way to be able to help with the workflow of the clinicians to get the job done. Do we have a common goal? Do we have a common purpose? And do we have a way of actually using that in such a way to help with this common goal and purpose? And that's going to be true of predictive analytics. As the more powerful it gets and the more facile we have with technology, the more challenges actually will become in terms of human factor engineering of how we actually make it useful.
Yeah, that's a great point.
Fantastic. Jonathan, very, very briefly, if I can, and I don't want this to be a sales pitch per se, but can you give us a quick 60-second grab of where Intel's technology has powered some of the things that you've been working on within the Google space and the types of things you've leveraged within their platform?
So obviously, Google's data centers leverage a tremendous amount of Intel CPU horsepower there. And one of the examples from a client perspective, Planet Labs is a company that tosses these little kind of bread box sized satellites out of the back of really anything that's going into orbit, and they do line scans of the Earth. Basically, once a day, you get a snippet of the Earth, and they stitch these all together. And using that power that's inside our data centers, they're able to then, kind of leverage some of the analytics, machine learning around vision, and then put that into a database for different things. And one of the areas that's been exposed with that, again, from another company that came in and used that data in our cloud, again, using the CPUs from Intel, was a company that came in and, everybody knows those little those big oil storage units that look like giant drums. What many people don't know, because you're looking up from this direction, but if you look down, it's very different, is they have a top that moves up and down so that as the oil actually drains out of those, they don't crumple underneath the vacuum pressure. And so as those drop down, the satellites notice a large shadow, and they can actually determine how much oil is in those based upon how large the shadow is.
Wow.
And so one of the things that they did with analytics in Google Cloud, again, using the CPUs from Intel in this sense, was then they could predict exactly what, at that moment, once per day, what the total reserve of oil is across the world. And you can imagine there's a few hedge funds on Wall Street here that are really interested in that information.
Very vested interest in knowing what
so
that was.
That's one of the journeys that our customers have been through.
Fantastic, thank you. Bob, I'm going to come back to you here. In true speed dating form, give us some quick sound bites around the three key tenets we spoke about today in general, particularly the competitive advantage that you can gain from adopting analytics, learning from the early adopters and the successes they've had, and thirdly, how to learn from their mistakes and avoid them in particular, and the pitfalls that they might have found.
Yeah, thanks, Des. So I think what I'm going to say here is really going to touch upon the things that Jonathan and Michelle said. So around competitive advantage from analytics, the highlight or the key for me is to learn from the best. So not only in your own industry, but in all the different industries, somebody has solved a problem that maps to a problem that you have. So look for that. And in fact, that's an area where I can help you because I'm working with all of them and I can bring that perspective to your problem, and then you can replicate that successful solution. So now you're more competitive in your marketplace because someone else developed something elsewhere. Second, from the point of view of learning from early adopters, the trick is that you really want to, what we've seen from our early adopters is that they start by asking a question that is going to move their business forward. And then furthermore, the successful early adopters think very carefully about how they're going to put those answers into action. So that touches upon what Michelle said, that it's okay to have analytics and results, but they don't do anything unless you can put them in place. So it's a two-step thing. And then if you think about what can we learn from the places where people had missteps, the most common misstep that I've seen is to put the data first. We're going to assemble all our data into a data lake. Look at this amazing thing. The insights are just going to bubble up to the surface of our data lake, right? And the answer is, well, unfortunately, no. You actually start with the question. And you've heard me say it before. Start with the question that has business value, something that you need to know. Work backwards to the data, the technology, and the people so that you can answer that question.
Fantastic. So I know we're getting close on time here, so let's just quickly regroup on what we've covered today. Gaining advantage from analytics in general, looking to where others had successes and leveraging those, and avoiding common pitfalls and so forth. If we were to synergize this in one big story, I'd like us to wrap up also with something we spoke about earlier. The trick is to start small and look where you can gain some of these wins in my experience, but also make sure that you can scale. And I'm sure, Jonathan, you'll agree with this. But also, as Michelle, you highlighted, make sure that you actually have humans curating and checking this stuff, because you can't just put it out and play and pray that it's going to work, because in many cases it's going to have very serious impact, and one of us may actually be in the hospital being checked out by the team at Montefiore. Bob, just in closing, a lot of folk in this room are going to have organizations where they're at multiple stages of maturity for their journey through zero to hero, from no analytics capability in big data and data science practices. In 60 seconds or less, if you can, before we wrap up, what kinds of insights can you share from Intel's experience, given that you're out of the coalface every day, literally at the coalface, around the challenges being faced by medium to large organizations who have different divisions at different parts of the journey through analytics and so forth, and having to deal with addressing those at different times in different ways?
Yeah, so I'll just focus on the main point. So we used to think about organizations being at some point on the analytics maturity curve, from basic reporting up through more advanced statistics, machine learning, advanced analytics, and predictive analytics. Now we've realized that actually pockets of organizations are at different places. So the key thing that I've observed is that the parts of the organization that are most advanced are the ones who have found metrics that they can use to measure the impact of their analytics that are most closely attached to the bottom line. That's the number one thing. So if you're looking for a way to boost the analytics of your group within your organization or with your organization as a whole, find ways to tie your analytics to value, or at least to have a very clear metric that people can understand that your analytics have moved the ball forward. It's critical.
Perfect. Michelle, thank you so much for your insights today and your time, and I think you're probably the prime example of taking big data and data science to an actual, not just a data problem, but a problem that actually applies data science to medical science and saves lives. Jonathan, thank you so much for your time and your insights. Love the anecdote around the chasing illegal fishermen, and hopefully we'll avoid 10,000-year recovery times. And Bob, thank you so much for having us here today. It's been great to get your insights.